easier to open when I do. Okay, where do we want to start?
Okay, I'd like to start at 21.
I was going to say, these look familiar. We did some of these already, I know.
Yeah, but this time it's like 21 and beyond.
Okay. So we're talking about circles. So the very first thing we want to know is the equation, the general format for the equation of a circle. What is it? Always have to start there. Now, let me give you a tip. If you had to look on a piece of paper to see this, then you're not ready for your test.
Okay.
By that, what I mean is when you're trying to
memorize it.
When you're trying to memorize stuff, it never works to always look on the piece of paper or the book to see it and then write that down. Okay, the way you want to do it is kind of like a flashcard. See if you know what it is first in your memory. And if you don't, then start working on memorizing it so that every time you have to write it, you're not looking at a book or a piece of paper to get it. Because when you take your test, they don't give you this, I'm sure. They need you to know this from the start. What are H and K? What does that mean?
The X and the Y.
No, that's the center of the circle. Yeah, that's the coordinates for the center of the circle. In other words,
Okay.
if I had a circle that was there, and that center had coordinates 3, 4, then H would be 3 and K would be 4. And if it had a radius of 2, then it would be the equation of that particular circle would be x minus 3 squared. You always leave it like that. You don't ever expand that, at least not yet, equals 4. And that would be the equation of the circle. In other words, when you get done, you still have an x and a y, but you don't have the h and the k anymore. All right? But this is always the starting spot, is to be able to write the general equation whenever you're doing any of these kind of problems. That's where you want to begin. Now, let's see what they say here. Okay, so their center is at H and K, and problem 21, they're telling us that it's 0, 2. So H equals 0, K equals 2, and radius, they're calling it A, I'm going to call it radius equals 2. So, what's the equation of that circle for 21?
It would be X minus 0 squared.
Which is just x squared.
True, because the 0 doesn't have to be there. Plus Y minus 2 squared equals 4.
All right, hold on 1 minute. Let me let my dog in.
Okay.
She don't like being locked out. Come on in. Okay, and 22, it's a little different. H is minus 1, K is 5, and A is square root of 10. Okay, so here, let me erase this one. What's the equation of that circle?
That would be X plus 1 squared plus y minus 5 squared equals 10.
Correct. 23. It's the equation of that circle.
That one will be x plus square root of 3 squared plus y plus 2 squared equals 4.
Good. And
He also told me that he wants me to like solve for x and y in the future.
what's that?
He also wants me to solve for the x-intercepts and y-intercepts too.
Ah, that's different. Okay, I see the rest of the instructions. Then sketch the circle, including the circle's center. Also label the x and y-intercepts with their coordinate pairs. All right, let's go back to this first one, which was x squared plus quantity y minus 2 squared equals 4. So how do I graph that? Where do I start?
Could I do the square roots to get rid of the squares?
No, actually you can't do that. In other words, I can't take the square root of the left side and get rid of the squares. Not only that, I don't want to. In other words, I know that's the equation of a circle, right? Well, there's only two things that matter with a circle, and that's its center and its radius. So where's the center of this circle? It's H.
Could I define the x and y intercepts?
Not yet. We'll get to that. First of all, we got to graph the circle. In other words, the middle part of these instructions, then sketch the circle, including the circle's center. Well, that's what you always start with, is the center. So where's the center of this circle? What's H?
H is...
Where's the center right there? On 21, they give it to you. It's 0, 2.
Oh, okay. So then it would be...
So 0, 2 is right there. That's the coordinates of that point. And that is the center of my circle. And I know the radius is what?
2 or 4.
No, it's actually 2.
Oh, really?
Well, look at the problem they gave us. A was 2.
Oh, yeah, since it's not
that's
squared.
r squared. On the right side of the equation, you have r squared. So to find the radius, you do need to take the square root of whatever that number is.
Okay.
Okay. Now, in this particular case, that's going to make that circle exactly tangent to the x-axis. But regardless of our drawing, how do I find the x and y-intercepts starting from that equation? How would you find the x-intercept?
I would have to plug zeros in for y.
For y, okay. So what do you get? You get x squared plus 4 equals 4, right?
Yes.
You plug in 0 for y. Remember that you're squaring minus 2, which becomes positive 4. So now we get x squared equals 0, so the x-intercept is 0. And there's only one of them. And we can see that there would only be one. It's tangent to the x-axis, right?
Yes.
Okay. Now let's figure out the y-intercept. Well, figure out the y-intercept, you're going to do what?
Plug in 0 for x.
Okay, which gives you y minus 2 squared equals 4. Solve that equation for y.
That would be, could I do square roots in this case?
That's definitely the thing you want to do. In other words, if you expand this and move the 4 over, you're going to have a quadratic that you have to factor. Well, it's much easier to solve this problem by taking the square root of both sides. So what's the next line?
Y minus 2 equals plus or minus 2.
Good. And the plus or minus is very important there. So what's the solution? What are the y-intercepts?
So it would be y equals plus or minus 2 plus 2.
What are those two answers?
I believe it would be 0 and 2.
Okay, the first answer is going to be the plus 2 plus another 2, so that's going to be 4.
Okay.
Second answer is going to be minus 2 plus 2, and that's how you get the 0.
Oh, okay, that makes sense.
And that's what the plus or minus means, is that it's two different answers. I could write this as y equals plus 2 and y equals minus 2. That's the same as saying y equal plus or minus 2. Okay? So whenever you see the plus or minus, it means you have two solutions, one that has the plus, one that has the minus, and we can see that that makes sense because there's one y-intercept, there's the other one. And they appear to be exactly at 0 and 4. Let's take our second equation, which was x plus 1 squared plus y, I think that's minus 5 squared equals 10. Sketch it. Where's our starting point?
So that means we would start off at -1 and 5.
As what?
As our center of the circle.
Okay, so there's our center. That's point C. And to draw the radius is square root of 10. Well, what is that? Here, let me label this point. Minus 1 comma 5. Square root of 10 is about what? It's about 3 and change?
Yeah, I believe so, around there.
In other words, if you don't have a calculator in front of you, you don't really need one. You're just trying to approximate it to draw the graph. And the thing that's important is, does my graph go all the way to the x-axis? And it doesn't, because square root of 10 is 3 and a little bit, and I'm 5 units away from my x-axis. So my circle is going to look something like this, right?
Yes.
In other words, it's not going to go, we're not going to have an x-intercept. And you'll see why in a moment. But that's a decent graph, and it does go through the y-axis twice. So we would expect to have 2 y-intercepts and no x-intercepts. Well, let's solve for the x-intercepts first.
Okay, so plug 0 into 1.
Okay, so what do you get?
So that would be x plus 1
squared plus
25 equals 10.
And now notice what happens. Is you get x plus 1 squared equals a negative number. And now you can't take the square root of both sides to solve for x, because when you take the square root of minus 15, that's an imaginary number. And imaginary numbers basically mean that you don't cross the x-axis. Okay? So there's algebraic confirmation that we don't cross the x-axis, even though we already knew it. Now solve for the y-intercepts, which aren't so obvious.
So would x not exist?
No. What's y-intercept mean regarding x?
No, I'm saying about the intercept that couldn't cross the axis.
Yes, the x-intercepts do not exist.
Okay.
Not that x doesn't exist, but the x-intercepts there are none.
Okay.
They're not zero, they're not imaginary, they're none. In other words, if we look at this, we can absolutely see that it does not cross the x-axis. But it crosses the y-axis in two places. So when we solve for the y-intercepts, we better look for two answers. How do we solve for the y-intercept?
So we plug in 0 for x.
So that gives us 1 plus, and you can see why you don't expand this. It would just make the problem harder. Okay. Now we're going to take the 1 to the other side, so we get y minus 5 quantity squared equals 9. Take the
Square root of everything.
So you get y equals plus or minus 3. So what are my two y-intercepts?
So I'm about to add 5. So it'll be y equals plus or minus 3 plus 5. So y equals 8 and y equals 2.
And that also fits our picture. It's always nice to do that last check. You can pick up a lot of mistakes that way. By, in other words, obviously if we came up with a y equal minus 2, let's say we made an algebraic mistake, well, I can look at that picture and tell there's no way y is getting to minus 2. It's got to get below the x-axis for that to happen. So I would pick up that mistake. All right. Let's graph 23. We start where?
So in 23 we start at negative square root of 3 and negative 2 as our center of the circle.
Yeah, square root of 3 is 1.7. So if I start negative square root of 3 and down 2, we'll label that negative square root of 3, comma, plus 2 or minus 2?
It'll be plus 2.
No, it's a minus 2.
Minus 2.
I was trying to remember and I couldn't remember.
Okay, I thought
That's our center, and the radius is 2. Well, that means it is going to go up to the x-axis. No, hold it. No, it isn't. It's going to be tangent to the x-axis again. But it's going to cross the y-axis twice again. And notice how I know that it's tangent to the x-axis. Because the y-coordinate is minus 2, and the radius is this distance.
Oh, okay, true.
Okay. However, let's examine the equation. It's x plus square root of 3 squared plus y plus 2 squared equals 4. And the radius was 2. So what's the x-intercept algebraically?
So put a 0 for y, so x plus square root of 3 squared plus 4 equals 4.
Plus square root of 3 squared plus
4
equals 4. So x plus square root of 3 squared equals 0. So x equals, why am I getting this answer? Hold on, let me think for a moment here. Why am I confused? When I plug in 0 for y, that's going to give me the x-intercept. And I can see that the x-intercept should be 0, right?
Yes.
You got a radius of 2, and we're exactly 2 units. The center is below the x-axis. So what am I doing wrong here? Hold on, thinking. So if I take the square root of both sides, I get x plus square root of 3 equals 0. X equal minus square root of 3, which isn't correct. What the heck am I doing wrong? Can you see it, Taylor? Sometimes you're staring at a mistake right in the face and you can't figure it out.
I'm going to check through my work again just to make sure, because I don't see anything either. So 0.
Well,
2,
let's figure out the y-intercept and see if that will illuminate the problem.
Okay, so x is
I'll
a 0.
assume that that's correct, even though I know it's not. But now let's figure out the the y-intercept. The y-intercept is where x is equal to 0. So now we have square root of 3 squared is 3 plus y plus 2 squared equals 4. So we have y plus 2 quantity squared equals 1. Y plus 2 equals plus or minus 1. So y equals minus 1 and minus 3. And that looks right. In other words, that looks like minus 1 and minus 3.
Yes. I agree with that.
This must be doing something wrong with my algebra here. Well, let me go back and erase everything that I've written, because it feels to me like I have to be doing something wrong. X plus square root of 3 squared plus y plus 2 squared equals 4. Okay, now let's solve this again. We're going to solve it by substituting 0 for y. So I have x plus square root of 3
squared
plus 2 squared
equals 4.
Now I get x plus square root of 3 squared equals 0. Gives me x plus square root of 3 equals 0. It's the one time you don't need the plus or minus. And
Okay.
X equals minus square root of 3. Only. Ah, well, that's exactly where it is.
True.
In other words, that point,
oh yeah, that makes sense.
Minus square root of 3 comma 0. That's the x. That is minus square root of 3. I was expecting it to be 0, and I couldn't figure out why I kept not coming up with 0. That's because it isn't 0.
Tangent.
Yeah, it's tangent to the x-axis, but it actually touches the x-axis at minus root 3. Well, there's an excellent problem as to why you should always do it algebraically and not graphically. Although I don't know why I couldn't see it graphically. I mean, I knew that this line, the center was at minus square root of 3. I should have known that's the same thing. In fact, you don't need to do it algebraically. You know exactly that it's minus square root of 3 if you look at it. All right, let's look at 24 and 25 because those both involve completing the square, which can be a little tricky.
Okay.
I think we talked a little bit about this, maybe not, at our last session. What we have here is the equation of a circle in standard format. Okay?
Okay.
Graph the circles whose equations are given. Okay, in order to graph a circle, you kind of need to put it in the standard format, right? In other words, It's going to be awful hard to graph that by just the x and y intercepts. What if I came up In other words, I could figure out the X and Y-intercept in standard format, but let's say I had a Y-intercept right there and an X-intercept right there. Well, what circle goes through that? It could be this circle. It could be this circle here. In other words, it's difficult if you just know the intercepts how to draw the circle. So the secret here is to put it into standard format, always. And then you'll be able to graph it. And once you graph it, then you do the same process that we did on the other problems, which is to find the X and Y intercept. But the way we put this into standard format, remember we have to make it look like this. That's standard. Well, this is actually conic section standard format. This is polynomial standard format. There is a difference. Okay, so if I want to put the polynomial into the conic section standard format, then I have to group my x's together. Here's the technique. You put your x's together and you leave a space for completing the square, and you put your y's together and you leave a space for completing the square, and you put your number on the other side. And the key always, whenever you're completing the square like this, is to make sure that you do not change the equation. Remember, I'm not trying to change that equation. I'm just trying to get it into standard format. So I'm never changing it at any point in time. Okay? What's the next step for completing the square on the bottom line? How do I complete the square in the left parentheses?
X squared plus 4x.
Well, you take half of the coefficient of the x term, which is half of 4 is 2, and you square it, and you add it, like that.
Okay.
Now, I just changed the equation, right?
Yes.
In other words, when I wrote plus 4, I added 4 to the left side, so I got to add 4 to the right. Now they're the same. Now I got to complete the square on the y term. You do the same thing. You take half of the coefficient of the y term, square it, and add it inside the parentheses. So I'm adding another 4. And it's always being added, because even if it's a negative 4, half of that's negative 2, but I've got to square it, so it's always a positive number when you're completing the square. Again, I added 4 to the left side, I got to add 4 to the right. Now, why did I complete the square? So I could write this as an x minus h quantity squared, and I can now do that. In other words, this thing in the parentheses over here can now be written as x plus 2 quantity squared. That's the whole reason we complete the square, is so that we can write it like that. How can I write the y part?
So for y, I would have to do the same thing, half of the coefficient.
We already completed the square, but now the secret is, how do I write that as a linear term squared?
Would it be?
Always whatever half of that coefficient was.
Okay.
Okay, always.
But if you square it, wouldn't it be positive?
Well, notice that y minus 2 squared is this quadratic right here. I don't know if you can see where I'm pointing. I don't think you can anymore, which is unfortunate. I don't have a way of pointing. But y minus 2 quantity squared is y squared minus 4y plus 4. Okay? Now, the right side is minus 4 plus 4 plus 4. So it ends up plus 4. So this is now my rewritten equation of this polynomial. They're identical. Only thing is, I now have it in the perfect form of a circle, and I can graph it. Where's my center?
Okay.
Where's my center?
The center will be at 2 and negative 2.
Reverse it.
Reverse negative 2 and 2.
Remember the standard. The standard is x minus h and y minus k. So the center, h has to be a negative 2, right?
Yes.
And k has to be positive 2. So there's the center of my circle right there at negative 2, positive 2. What's the radius?
4.
No, it's always the square
Two because it got squared.
root of that number. And that gives me a circle that is perfectly tangent with both the y-axis and the x-axis. Now, let's find those intercepts. Do we have to go through the algebra or can we tell? What's the x-intercept?
So 0 for y. So that'll be x plus 2 squared plus 4 equals 4.
That's why I said, do we need, you're going through the algebra, and I have no problem with that. That's
Okay.
always the safe way to do it. But look at my sketch. Look at my picture. If we're tangent, then this point right here has to be minus 2. And this point right here for the y-intercept has to be plus 2. So the x-intercept is only one number, minus 2, and the y-intercept has to be plus 2. And I don't have to go through the math. I can tell. In other words, because the center is at minus 2, 2, and the radius is 2, I know it's going to be perfectly tangent with the x-axis and perfectly tangent with the y-axis. And the only way that can be is if that is there and that is there. So I can dispense with going through the algebra. And the algebra isn't that easy. In other words, plugging in 0 for y and then solving the equation gives you the x-intercept for sure, and vice versa for the y-intercept, but that's a lot of math. And it's better if you can look at this picture and realize what the x and y-intercept have to be. Kind of like in the previous problem where I couldn't see it. How do you go backwards on this thing? I don't know. In other words, in the previous problem where I kept looking for that x-intercept, it was negative square root of 3. Well, I could have said that if I had just looked at the picture without doing the math. All right. Let's look at 25. So you work me through how we're going to do 25. Hold on. Yeah, let me start over here. I never leave myself enough room on the left. This is in polynomial standard format. Put that in circle format, circle standard format.
Okay, so that would be x minus h squared plus y minus k squared equals r squared.
Right. Now figure out what the only way you can figure out the h and the k and the r is to go through the completing the square process. So gather all the x.
Oh, so we just
There's only that for x. Right?
yes.
Now gather the y terms. Hold on, let me do
Y squared minus 3y.
correct. Hold on a second. I'm going to put that square outside.
Okay.
So this is y squared minus 3y. And then what else am I going to
do? Equals 0.
Now we're going to take this number and put it on the other side.
Oh, so we bring 4 to the other side.
Right, because remember what the standard format is. The standard format is x minus h squared plus y minus k squared equals r squared. So we need a number on the right side at some point. Now, we don't have anything to do here. We know what h is immediately. H is 0. But complete the square on the y. What is a plus?
So plus half of 3.
Squared.
Squared half of 3.
Half of 3 is 1 1/2, or 3 halves.
So it would be 3.
Halves, and you get 9/4.
9/4. Okay.
Now, what do I have to do to balance out the fact that I just added 9/4 to the left side of the equation?
You would have to subtract 9/4.
Now, you got to do the same thing. Plus 9/4. In other words, I'm trying to not change this equation. That equation is now identical to this equation. If you were to simplify the bottom equation, you'd get the top equation. Okay? And the beauty of completing the square is that once I've done it, now I can write it in standard circle format, which is x. I'll even put the 0 in just to be a little clearer. How do I write that?
We would have to put another 0.
No.
On the other side to even it out.
We completed the square so we could write it as a linear term. And the way you write it as a linear term is you take whatever half that was and you put it here. That's how you do it. In other words, if you were to square y minus 3 halves, you'd get this y squared minus 3y plus 9/4.
Okay.
That's why you complete the square. Completing the square is always for one purpose only, and that is so that you can write it as a linear term. Y minus 3 halves is a linear term, not a quadratic term. The whole quantity is squared. Now, over here, I've got 16/4 and 9/4. That's 25/4. Okay? You with me?
Yes.
Okay. Now, how do I graph that? Where's the center?
The center will be -3/2 and 0.
What's the x-coordinate of the center?
0.
So you reversed it.
Okay, so it would be 0, and the y would be -3/2.
Oh, it's always y minus k. So k has to be positive 3/2.
Okay.
So there's my center right there. That point is 0, 3 halves. What's my radius?
25/4 squared.
That is the radius squared. So to get the radius, you have to take the square root of that.
So that would be 5/2.
Correct. And 5/2 gives you a circle that does go down and touch both axes. Now, to figure out those intercepts, I do have to do the algebra. And the easiest place to substitute the algebra is going to be into that equation, not the top one.
Okay. So if I'm solving for x, I put 0 in for y.
Okay. So now
So
I have
x minus,
x squared minus 9/4 equals 25/4. Solve that.
yes, so then square root after I
Yeah,
do the plus
not yet. You got to
9/4.
get all the numbers on the right side before you can take the square root of both sides.
So I add the 9/4.
Okay, which gives you
Would
30,
it be
34
34?
fourths. Now what?
Then I square it.
And you take the square root of both sides.
Yes.
We can see that there's two x-intercepts. There's one right there and there's one right there.
Mm-hmm.
So we better come up with two answers. Well, x is what? What's one of them? What's the other?
I don't know the square root of 34.
So you write it as square root of 34. That is simplified. But the bottom becomes 2.
Yes.
So this is the correct answer. And that gives you your two x-intercepts. One is at plus square root of 34 divided by 2, and the other is at minus square root of 34 divided by 2. And this is the way you want to give the answer. You don't want to give the answer as a decimal. A decimal would be an approximation, because square root of 34 is an irrational number. So you can't give me a decimal that's equal to the square root of 34. So all you can do is approximate it. It's between 5 and 6, but that's all I know. Okay.
Mm-hmm.
So now let's figure out the y-intercepts.
So I put a 0 in for x.
Oh, hold on, I got to figure out. I need to figure out how to get more room. All right. Well, we know what the x-intercept is. So when you put in 0 for x, now what's the rest of the equation?
It eliminates that whole side. So it'll just be y minus 3 over 2 squared equals 25 over 4.
Okay, next step.
So then y minus 3 over 2 squared equals 25 over 4. So would I have to square root to get the 3 over 2 free?
Yep.
Okay.
Which means you have to take the square root of that also. So that's the next step.
Then I add 3 over 2 to 5 over 2, and that would be 8 over 2.
Well, it's a plus or minus 5 over 2.
Plus or minus 5 over 2 plus.
One of them is 4. That's the 8 over 2. What's the other one?
So that one will be, so minus negative 8 over 2.
No, it's negative 5 halves plus 3 halves.
So that would be negative 2 halves.
Which is negative 1. So there's your two y-intercepts.
Okay.
Okay, and that's what you want to do with all of these problems. Let's do 26. This completing the square goes a lot further than just circles. In other words, you're going to have to complete the square when you study parabolas, hyperbolas, and ellipses. It's an integral part to solving all of them. So it's not just going to be for circles, because all of the formats are all in a similar format as a circle. In other words, the equation of an ellipse is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Which means that if you took a regular polynomial and it was an ellipse, for you to figure out how to graph it, you got to complete the square. Same with a hyperbola. So it's a very common process. So what's my first step here?
So I have to get all the x's together.
Okay, so read the next line from me.
So it'd be parenthesis x squared minus 4x.
And then leave space. And
Then it will
just as a reminder, I'll put a plus sign there to remind you that you're going to have to complete the square and it's always a plus number.
Okay.
And then what?
Then I have to get the y's together, and that'll be y squared plus 4y.
Okay, there is no constant, so it's 0 on the other side. Now complete the square on both pieces.
It'll be 4, so plus 4 on the x. Then for the y, it'll be plus 4 as well.
So how much is the right side? What do I have to do to the right side?
I have to add 2 plus 4s, which will be a plus 8.
Okay. Now rewrite both of these quadratics as linear terms squared.
Okay, so that'd be x minus 2.
Correct?
Squared plus y plus 2 squared equals 8.
Now you have everything you need. Where's the center of my circle?
Negative 2 and 2.
No, don't get it backwards. Always remember it's x minus h and y minus k.
Okay, so, okay.
In fact, until you get to calculus, everything in math is x minus h, y minus k. When you're talking about the vertex format for a quadratic or a parabola, it's x minus h. It's always minus. Very first time that you encounter pluses is when you get to calculus. Then it's f of x plus h. But it's always going to be minus with these conic sections.
Okay.
Oh, I see at the top of this page, you do get into ellipses. That's see at the top here where I'm pointing of your page 5?
Yeah.
That's the standard equation of an ellipse. Notice that it's not quite the same as a circle, but it's close. It's still x minus h and y minus k. Okay, back to a problem 26. Where's the center?
2 and negative 2.
What's the radius?
Square root of 8.
Which simplifies to
2 root 2.
okay. And so 2 root 2's going to cross both axes. Now what's the x and y-intercepts?
Okay, so for x, I equal the y to 0, so it'll be x minus 2 squared plus 4 equals 8.
Next step.
Square root.
Next line.
So it'll be x minus 2 equals 2 plus 2. Or no. Plus or minus 2.
Okay, which makes what 2?
It'll be x equals plus or minus 2 plus 2, which will be the x-intercept is either 2 or 0.
It's 4 or 0.
Or 4 is 0. Darn it, I forgot about that.
In other words, the first one is plus 2, and the second one is minus 2 plus 2.
Plus 2.
Okay, so those are our x-intercepts. Now let me erase this to make a little room. And what's our y-intercept?
So I plug 0 in for x, so it would be 4 plus y plus 2 squared equals 8. Then I subtract 4. Then I do the square root, then it'll be y plus 2 equals 2, plus or minus 2. Then I subtract the 2 from both sides. Then y equals plus or minus 2 minus 2. So if it's a plus 2, it's y equals 0. And if it's a minus 2, it's negative 4.
There you go. And that's how you do those problems.
Okay, perfect.
Okay. Have you gotten to ellipses yet? I'm a little surprised that ellipses are up here and they're giving you problems on circles down here.
I haven't gotten to ellipses yet.
You haven't? Okay.
No.
The key on all of them is the standard general format. In other words, this thing up here. You want to memorize them for the circle, for the ellipse, and for the hyperbola. The only difference for a hyperbola is that becomes a minus sign. So the standard equation of a hyperbola is very similar to an ellipse. It's just subtraction going on in the middle instead of addition. And the key also is the 1. They're always equal to 1 on the right side. Not the radius squared, but 1.
Okay.
Okay. Any other questions for tonight, Taylor?
Nope, I believe that covers it all. Have a good night.
You too. Talk to you later.
Thank you. You too. Bye.
Bye-bye.